class, we'll be taking a renal plasma flow. So let's go. Ideally, one would simply choose a substance which neither is synthesized nor metabolized by the kidney. So, for clearance, substance that are not sure that the kidney synthesizes or metabolized by the kidney. So the amount of such a substance entering the kidney per unit time via the renal artery should equal the amount leaving via the renal vein. So what we are saying is, when a person is being given that particular amount, if for example we are doing clearance, so when that person is given that amount of substance, the amount that enters at a particular time, it should also be the same amount that is coming out. So with that, you'll be able to know if the kidney is functioning properly. So however, it is not trivial to obtain blood samples from the renal vein in humans, and therefore another approach is needed. PAH, which is also known as capital letter PAH, capital letter PAH, known as para-amino hypurate. It works, although it is not filtered at the glomerulus. It undergoes tubular secretion in an extremely sufficient manner. About 90% of all PAH is removed from the plasma via secretion, while 10% remains in the renal vein. So this material, this PAH, para-amino hypuric acid or hypurate, would have been a very good clearance substance, because when it is being given to an individual, about 90% of it is being filtered out. I hope you can hear me. So about 90% of it is being removed by the kidney, while it just retains 10%. So that 10% most times is considered as not significant. So let's go ahead, and this 10% is ignored, and it is then assumed that the amount entering the kidney equals the amount showing up in the urine. So the amount entering the kidney equals the amount showing up in the urine. Continue. So there is a mathematical representation of this renal plasma flow. So if you're asked to calculate renal plasma flow now, so renal plasma flow times PAH, para-amino hypurate in plasma, is equal to PAH in urine times urine flow rates. I go again with the formula. If you're asked to calculate renal plasma flow, you can actually calculate it from this. So renal plasma flow times PAH in plasma is equal to PAH in urine times urine flow rates, which can also be known as V. So let's continue. Now, although this test is rarely used in clinical practice, it's essential for research studies in which hemodynamic effects of various drugs can be measured. So if, for example, one wants to look at how well this PAH can function, it can be used for research purposes, maybe in animal studies. You know, for example, now ACE inhibitors, capital letter ACE inhibitors are associated with a measurable increase in ROCF. So I've talked about renal plasma flow, trying to look at the amount of substance that is being filtered by the kidney at a particular time. So when this is done, substances which the kidney doesn't synthesize or metabolize are being used, so that the same amount that goes in should also come out. So I'll be able to know. So if at the end of the day you give 5 and none is coming out at all, or 1 is coming out, you know that there's a problem, there's something wrong with the kidney. So with this, we'll move to our next topic in our next class, which is glomerular filtration rate. See you in my next class.